Before the Big Bang, space, time, matter, and energy did not exist. There was no universe, no stars, and no planets. Everything that would later become the universe was compressed into an infinitely small, extremely hot, and dense point called a singularity. At this stage, the laws of physics as we know them could not operate. We cannot describe what happened before this moment because time itself had not begun. The Big Bang was not an explosion in space. Instead, it was the creation of space itself. About 13.8 billion years ago, the singularity began to expand rapidly. As this expansion started, space was created, time began to flow, and energy transformed into matter. The universe expanded in every direction at once, and this expansion continues even today. Imagine the universe like a stretching rubber sheet. As it stretches, every point moves away from every other point. This is how the universe began, from a single beginning into everything we see today. The Big Bang, the universe was extremely hot, with temperatures reaching trillions of degrees. At such high temperatures, atoms could not exist. As the universe continued to expand, it began to cool down. This cooling was essential for the formation of matter. First, energy transformed into subatomic particles, such as quarks and electrons. Quarks then combined to form protons and neutrons. After about 380,000 years, the universe cooled enough for protons and electrons to join together, forming the first atoms. Only light elements could form at this stage. About 75% hydrogen and 25% helium filled the universe. Heavier elements could not form yet because the temperature and pressure were too low. Slowly, gravity began to pull these atoms together. Large clouds of gas formed, called nebulae. These nebulae would later become the birthplaces of stars. Inside massive gas clouds called nebulae, gravity caused the gas to slowly collapse. As the cloud became denser, pressure and temperature increased at its core. When the temperature reached about 10 million degrees Celsius, a powerful process called nuclear fusion began. Hydrogen atoms fused together to form helium, releasing enormous energy. This energy made the stars shine and marked the birth of a star. Nuclear fusion also prevents stars from collapsing under their own gravity. It creates a balance between outward energy and inward gravitational force. Over time, billions of stars grouped together due to gravity. These massive groups formed galaxies. Galaxies come in different shapes, such as spiral, elliptical, and irregular. Our home galaxy, the Milky Way, is a spiral galaxy containing billions of stars, including our Sun. Stars are not just sources of light. They are factories of elements. Inside stars, nuclear fusion creates new elements. Hydrogen fuses into helium. Helium fuses into carbon. Carbon forms oxygen, and fusion continues up to iron in massive stars. However, stars cannot create elements heavier than iron through normal fusion. When massive stars run out of fuel, gravity causes them to collapse violently. This collapse leads to a powerful explosion called a supernova. During a supernova, temperatures and pressures become extremely high. This allows the formation of elements heavier than iron, such as gold and uranium. These explosions scatter elements across space. Earth, water, air, and all living beings are made from this star material. Without stars and supernovae, life would not exist. About 4.6 billion years ago, a giant cloud of gas and dust existed in space. This cloud, called the solar nebula, contained hydrogen, helium, and heavy elements from earlier stars. A nearby supernova shock caused the cloud to collapse under gravity. As it collapsed, the cloud began to spin faster. Most of the material collected at the center, forming the Sun. The remaining material flattened into a rotating disk around the Sun, called the protoplanetary disk. Inside this disk, particles of dust and gas began interacting and colliding. Over time, these particles started the process that would form planets. This solar nebula became the foundation of our entire solar system, including Earth. Within the protoplanetary disk, dust particles stuck together due to electrostatic forces. Small particles collided and merged, growing into larger bodies. This growth process is called accretion. As Earth grew larger, collisions released huge amounts of energy. Radioactive elements inside Earth also produced heat. As a result, early Earth became a molten ball of magma. Later, a Mars-sized object collided with Earth. This massive impact ejected debris into space. The debris gradually came together to form the Moon. This collision also helped stabilize Earth's tilt, which is important for maintaining seasons and a stable climate. When Earth was molten, materials could move freely inside it. This allowed differentiation where materials separated by density. Heavy metals like iron and nickel sank toward the center, forming the core. Lighter materials rose upward, forming the mantle and crust. Earth developed four main layers. The inner core is solid iron and extremely hot. The outer core is liquid iron and generates Earth's magnetic field. Above it lies the mantle, made of semi-molten rock. The outermost layer is the crust, the surface we live on. These layers play a crucial role in Earth's geology and magnetic protection. Early Earth had no atmosphere like today. Volcanic eruptions released gases such as water vapor, carbon dioxide, and nitrogen. Free oxygen was absent. As Earth cooled, water vapor condensed into clouds. Rain fell continuously for millions of years. This rainfall collected in low areas, forming the oceans. Later, early bacteria began producing oxygen through photosynthesis. Over time, oxygen accumulated in the atmosphere. This oxygen-rich atmosphere allowed the development of complex life forms and protected Earth from harmful radiation. Life began through a process called chemical evolution. In Earth's oceans, simple molecules formed naturally. Energy from lightning, heat, and ultraviolet radiation caused chemical reactions. These reactions produced more complex organic molecules. Over long periods of time, these molecules organized into the first single-celled organisms, about 3.5 billion years ago. These early life forms slowly evolved through natural processes. Simple organisms became more complex. Eventually, plants, animals, and humans appeared. Life on Earth is the result of billions of years of cosmic and biological evolution.